Welcome everyone in lecture number 16. In this video lecture, I will tell you today the first shifting theorem of inverse Laplace transform. Let me first recall you the first shifting theorem for Laplace transform. What was that theorem? If Laplace transform of ft is equal to fp, then Laplace transform of e raised to power at ft will be equal to Laplace transform of ft, where p is replaced by p minus a. P is replaced by p minus a. We can also write this as fp minus a. Okay. So if we try to write this property, this theorem for inverse Laplace transform, then in that case the statement would be, if I should write here for inverse Laplace transform, this property will be stated like this: if Laplace inverse of, first of all do the change this condition first of all. So if Laplace inverse of fp is equal to ft, so we write here, if Laplace inverse of fp is equal to ft, then now we write this condition for inverse Laplace transform. So कैसे लिखेंगे? Laplace inverse of fp minus a will be equal to e raised power at ft, or you can also write this as, अगर आप इस फॉर्म में लिखेंगे, इसको इस फॉर्म में अगर आप लिखना चाहेंगे तो कैसे लिखेंगे? इसमें तो नहीं लिख पाएंगे, हम इसको ऐसे लिख सकते हैं e raised power at, और ft को हम रिप्लेस कर सकते हैं लाप्लास इनवर्स ऑफ fp से. ओके, so if you have here fp plus a, so this is same, or Laplace inverse of fp is equal to ft, then Laplace inverse of fp plus a will be equal to e raised to power minus at Laplace inverse of fp. So these are two main theorems, two forms of this theorem, which is called first shifting theorem for inverse Laplace transform. So let's see one example quickly. Example number 1. Find Laplace inverse of p divided by p square plus 2p plus 5. यहाँ पर आप इस प्रॉपर्टी का यूज कैसे करेंगे? तो इसके लिए भी फर्स्ट ऑफ ऑल इसको हम कंप्लीट स्क्वायर में लिखेंगे, इस स्टेटमेंट को p अपॉन p स्क्वायर प्लस 2p प्लस 5. इसको आप लिख सकते हो लाप्लास इनवर्स ऑफ p अपॉन, इसको अगर हम कंप्लीट स्क्वायर बनाएंगे तो हम इसको ऐसे लिख सकते हैं p प्लस 1 होल स्क्वायर प्लस 2 स्क्वायर. Okay. Up, because this is p plus 1, so you have to make this also p plus 1, because we need a function of p plus a or p minus a. So this is already p plus a type, so we don't have any option to make this also p plus a. Okay, so we what we'll do here is we add 1 and subtract 1. Now we can write this as, separate these two. Okay, so one of these is 1 p plus 1 upon p plus 1 whole square plus 2 square, and the another one is Laplace inverse of 1 upon p plus 1 whole square plus 2 square. Now this become function of p plus 1. You can see this become function of p plus 1. So you can write, let me see the property. Laplace inverse of p plus a is equal to e raised power minus at into Laplace inverse of fp. Means in function p plus a will be replaced by p. So this is equal to e raised power minus t. Laplace inverse of, this will be replaced by p. This will be replaced by p and 2 square. This is already a function of p plus 1. So this is e raised power minus t Laplace inverse of 1 upon p square plus 2 square. Now it's very simple. Laplace inverse of p upon p square plus 2 square is cos 2t, and Laplace inverse of 1 upon p square plus 2 square, so we need here 2 to make it the sine 2t formula. Laplace inverse of a upon p square plus a square is sine at. So to make a here, we multiply and divide this expression by 2. So we have 1 upon 2 here, and 2 is assumed to be here. So we can write here as sine 2t. So we can simplify it by taking e raised power minus t common, or you can just leave it as it is. That's all. This is the answer. तो आपको क्वेश्चन में ये देखना है कि किस किस टाइप का फंक्शन बन रहा है, p plus a और p minus a. If you are getting some p plus a type of expression like the here we are getting p plus 1 type of expression in the denominator, then you have to make this p also of this type p plus 1, because the function, we have to make the function of p plus a or p minus a. तो पूरे एक्सप्रेशन को आपको फंक्शन ऑफ p प्लस a या p माइनस a की फॉर्म में लिखना है, क्योंकि इसमें हमने p को p प्लस 1 और p माइनस 1 इसलिए किया क्योंकि दिस इज p प्लस 1, बट इन दिस एक्सप्रेशन वी हैव p प्लस 1 ओनली हियर. अगर आपके पास यहाँ p प्लस p होता तो आपको उसको भी फिर p प्लस 1 p माइनस 1 करना पड़ता, p प्लस 1 सॉरी प्लस 1 माइनस 1. Let's see one more example. You can understand that easily. Example number 2. Find the Laplace inverse of p upon p plus 1 raised to the power 5. So here we have this question, p upon p plus 1 raised to the power 5. If you can see here, this is already p plus one type, p plus 1. So you have to make this also p plus 1. So for that, let's add 1 and subtract 1. Okay. Now separate both the terms. One is p plus 1 upon p plus 1 raised to the power 5. And another one is, let me write it in the next line because both are not coming here. This is equal to Laplace inverse of p plus 1, because p plus 1 and this is also p plus 1, so 1 p plus 1 will be cancelled out. So I should write here 1 upon p plus 1 raised to the power 4. That would be better. And this is Laplace inverse of 1 upon p plus 1 raised to the power 5. Now it is very simple to find the Laplace inverse of these two expressions. Or it is e raised power minus t into Laplace inverse of 1 upon p raised power 4 minus e raised power minus t into Laplace inverse of 1 upon p raised power 5. So Laplace inverse of 1 upon p raised power 4 is t cube upon factorial 4, sorry, factorial 3, and is t5 upon factorial 4. That's all. Sorry, it is t4. Next example is find the Laplace inverse of 1 upon p plus a square root. So how do we solve it? Laplace inverse of 1 upon square root of p plus a. This is already p plus a type of functions. Laplace inverse by first shifting theorem is equal to e raised power minus at Laplace inverse of 1 upon square root of p. So it is equal to t raised power minus half over gamma half. So it is e raised power minus at 1 upon square root pi t, because gamma half is square root of pi. Next example is, I think it's example number 4. Find the Laplace inverse of 15 upon p square plus 4p plus 13. Okay. Again we make it perfect square. This is equal to Laplace inverse of 15 over p plus 2 whole square, I think. And 9 is left, so we can write 3 square. So now this becomes the function of p plus 2. So this is directly equal to 15 e raised power minus 2t into Laplace inverse of 1 upon p square plus 3 square. 15 e raised power minus 2t, we need 3 here. So we multiply and divide the whole by 3. So this becomes sine 3t. 5 e raised power minus 2t sine 3t. Okay. Next example is find the Laplace inverse of p plus 8 over p square plus 4p plus 5. Again, we make the denominator as perfect square. This is p plus 2 whole square plus 1. Because this is a function of p plus 2, this can't be make as a, इसको आप p plus 8 से replace नहीं कर पाओगे, लेकिन इसको आप p plus 2 बना सकते हो. तो आप इसको लिखोगे p plus 2 plus 6. Now we separate this. This is, and we separate this. Separate these two. So we can write this as Laplace inverse of p plus 2 divide p plus 2 whole square plus 1 plus Laplace inverse of 6 over p plus 2 square plus 1. Now this Laplace inverse of p plus 8 over p square plus 4p plus 5 is equal to e raised to power minus 2t Laplace inverse of p upon p square plus 1. And next one is e raised to power minus 2t Laplace inverse of 6 upon p square plus 1. Now you can write the Laplace inverse of p upon p square plus 1 is cos t, and this is 6 will came outside, just sin t. E raised to power minus 2t can be taken common, cos t plus 6 sin t. That's all. In my next video lecture, I'll discuss second shifting theorem for inverse Laplace transform. Okay. I hope you understand the property of first shifting theorem for inverse Laplace transform clearly. Okay. So if you liked my video, you can press the like button. Please share it and subscribe my channel. If you have not subscribed my channel yet, to get the notification of any new video. Thank you so much.